So far in class, we have been talking about factoring, and we've also been talking about solving quadratic equations. And when we solve a quadratic equation, it's just an equation when x is squared. And so now we want to talk about quadratic functions, meaning when I have a variable that's squared, what does that look like when I graph it on a coordinate plane? This is very important because we are running out of time. You need to make sure that you are writing this, copying it down, and understanding what's going on. So you need to make sure you have a highlighter with you so you can follow along, just like we were doing this in class. So I'm going to highlight my title, Quadratic Functions. And I'm also going to, let's take a look at it. It says, so far we've only learned how to graph linear functions. That's the only thing we've learned how to put on a coordinate plane other than just plotting a bunch of random points. When we graph a linear function, what shape is formed? That shape that's formed is a line. The word line is hiding in a linear function. Next question. Make sure you get it right. I beg you from the bottom of my heart. When you hear the words equation of a line, what do you immediately think? Y equals mx plus b. I really hope you just said that out loud. In the equation of a line, y equals mx plus b, what two variables are the most important? M and b. I hope your family thinks you're crazy talking to a computer screen. So let's review, ladies and gentlemen. Graph the following example. Y equals negative 2x plus 3. When you graph a line, you need to know what m equals and you need to know what b equals. What does m equal? Negative 2 over 1. What's b equal? 3. What do you plot first? B. On what axis? The y-axis. From here, you go down 2 into the right one. Down 2 into the right 1, down 2 into the right 1. I'm going to keep going. I'm having so much fun. And I'm going to connect my dots, but I'm going to do a terrible job at it. Hey, not too bad. So, let's answer these questions over here now. It says, what is the slope? What's the slope, ladies and gentlemen? Negative 2, because it's always next to x. What's the y-intercept? The y-intercept is 3. What about x? How do I know, actually, let's pause. How do I know what the y-intercept is? Well, the y-intercept is where your line crosses your y-axis, and it crosses your y-axis right there. What about the x-intercept? X-intercept is where the line crosses the x-axis. Where do you think it crosses the x-axis? Well, it crosses the x-axis right there. Take a guess. What value do you think that is? Well, I think that's 1.5. We'll come back and see how we'd figure that out here in a second. Let's keep going. How do you know the equations of the graph? How do you know the equation above graphs a line where the example y equals x squared plus 2x plus 3 does not? How do I know that this equation right here graphs a line? Does anybody remember? Well, I know it graphs a line because there are no exponents in that one. This equation right here, it has an exponent of 2 in it, which means it doesn't graph a line. So how do I know the equation above graphs a line? There are no exponents. Really, there are exponents, but the exponents are hiding, so the exponents that are hiding are just 1. So I have an exponent of 1, which makes it linear. An exponent of 2 makes it something else. An exponent of 3 makes it something entirely different. Let's take a look. Given the example, this is fabulous SOL review. How do I find the x-intercept? X-intercept we just talked about. What does x-intercept mean? Well, it's where the line crosses the x-axis. But if I don't have a pretty coordinate plane like I did up here, how do I find the x-intercept? Does anybody remember? Well, I have to plug 0 into the opposite variable. So if I'm finding the x-intercept, I have to plug 0 into the opposite variable, which means I'm plugging it into y. So I'm going to plug 0 into y. And now I have to solve for x. So how do I solve for x? Well, I'm going to add 4 on both sides. So I have 4 equals 2x. And then I'm going to divide by 2. So what's x equal? 2. So my x-intercept is 2. So the ordered pair would really be 2, 0. If I wanted to find the actual x-intercept of this problem up here, I would plug 0 into y and solve for x. And sure enough, I would actually get 1.5. Obviously, not everything in life is formed by straight lines. A lot of times a line can curve, which obviously is no longer a line. Let's talk about throwing a basketball into a basketball hoop. If I were to take a basketball and I were to throw it into a basketball hoop and I were to throw it straight at the backboard, would it go in? No, because what has to happen? Well, my shot that I throw has to be curved. So when I have when I'm forming a curved function, a curved shape, those aren't called linear functions. Those are called quadratic functions. And a quadratic function is a function that graphs a curve. So now what about an equation? Where have we seen the word quadratic function? Well, we use the word quadratic when we're talking about quadratic equations. Quadratic equations have x squareds in them. So how do I remember which equations are quadratics? There must be an x squared in the equation. So let's take a look at some of these examples. Which of the following are quadratic equations? We're going to circle all the ones that are quadratic. Look at the first one. Y equals 2x squared minus 3. Is that a quadratic equation? Yes, because x is squared. What about the next one? Y equals 5x plus 2. Is that a quadratic equation? No, because I have no x squared. Look at the next one. Y equals 6x cubed minus 3x squared plus 2x minus 1. Is that a quadratic equation? Well, it does have an x squared, but that's not the biggest one. It actually has an x cubed, so no, that graphs something entirely different. And what about the last one? Yep, x is squared. Next one, it says the name of a curve a quadratic creates is what's called a parabola. It's a fancy word for a U-shaped curve. If you look down here, this graph is a U-shaped curve. It's a parabola. That's what we call a parabola. A parabola is just a U-shaped curve. If you want to write that down, you can. U-shaped curve. All right? We have some popular parts about the parabola. The first popular part is called the axis of symmetry. The axis of symmetry is a Vux line that cuts the parabola into two equal pieces. So my axis of symmetry would be right here. The next vocabulary word is called vertex. The word vertex, it is the lowest or highest point on a parabola. I'm going to be very mature about this. A vertex is the lowest or highest point. I call the parabola the butt. The butt of my parabola is right here. All right? Go ahead and flip your paper for me, please. A parabola can open upwards or downwards. A parabola opens upward when a is greater than 1. And what that means, your first term is positive. It opens downward when a is less than 1, which means a is negative. Quadratics have a standard equation. We got to write this down. Standard equation. Y equals ax squared plus bx plus c. This is my standard equation for parabolas. Notice A is right here. When this number is positive, it opens up. When that number is negative, it opens down. So let's take a look. It says these examples. Determine A, B, and C and determine if the following equations will open up or down. So A, B, and C are just the numbers. A is in front of x squared, B is in front of x, C is my constant. So A in this problem is 2, B is 3, and C is 3. Is this going to open up or down? Up. Why is it opening up? Because A is positive. Look at the next one. What's A equal? -1. What's B equal? 2. What's C equal? -5. Is this opening up or down? Down. Why? A is negative. Pause this video, try the next one on your own, and then unpause it. A equals 1/2. B equals 4. C equals -9. Is this opening up or down? Up. Why? A is positive. All right. When we're solving quadratic equations, our goal is to find the x-intercepts. No matter what it's talking about, chances are my goal is to find the x-intercepts. So I have 3 different types of solutions. Look at this first example. Where's my x-intercept? My x-intercept is here. Look at the next example. Hold on, let's pause. First example, my x-intercept is right here. That value, I have 1 solution. I have 1 x-intercept. Look at the next one. Where are your x-intercepts? How many times does this parabola touch your x-axis? Well, it touches here, and it touches here. So I have 2 solutions. Look at the last one. How many times does this parabola touch your x-axis? It never does. So since it never does, what do you think my solution is? No solution. 3 possibilities. My parabola can either touch my x-axis once, twice, or none. Those are your options. Whenever you're solving an equation that is a quadratic, your goal is to find the x-intercepts. That's huge. If it's asking what's the solution, it's wanting the x-intercepts. This next sentence is absolutely positively 120% important. If you're not paying attention in this video, you're just zoning out and you're copying all this down. Now's your time to pay attention. There are 2 other words that mean the exact same thing as x-intercept. We use them to confuse you. Those 2 words are called roots, or they are called zeros. When you hear the word roots, it means the exact same thing as x-intercept. When you hear the word zeros, it means the exact same thing as x-intercepts. X-intercepts is where your graph touches your x-axis. So let's take a look at these examples. Look at the following graphs and determine the roots of the following. Out of all of these words in the directions, what word means the most? Roots. When you hear the word roots, it means the exact same thing as x-intercept. So, looking at your first graph, how many x-intercepts do you have? You have 2. You have 1 there and 1 there. Can you tell me what those ordered pairs are? -2, 0, and 3, 0. Next one, x-intercepts. Where are they? Right here. Can you tell me what that ordered pair is? -1, 0. I want you to pause this video. You're going to do those 2 problems on your own. I will be checking to make sure that they are complete next class. When you're good and you finish those 2 problems, flip your paper. we can also find roots and zeros algebraically. When you see the word roots or you see the word zeros, you know they mean the exact same thing as x-intercepts. On the very front of this page, we talked about finding x-intercepts when I give you an equation. Do you remember what I said? You plug 0 into y, because that's the opposite variable. So, let's look at these examples. It says find the x-intercepts. So when you see the word x-intercept, that means plug 0 into y. So on 1, I'm going to plug 0 into y. X squared plus 3x minus 4. I then am going to solve for x. So, looking at that equation, how do I solve for x? Light bulb. X is squared. I have to factor. First question you ask yourself, is there a GCF? No. So, X method. -4 goes on the top, 3 goes on the bottom. Factors of -4 that make 3. 4 and -1. So I have x plus 4, I have x minus 1 equals 0. This equal sign tells me I'm not done. I got to split up my factors. X plus 4 equals 0. X minus 1 equals 0. So over here, x is going to equal -4. And x over here is going to equal 1. Ah, it's the exact same thing I've been doing. Next one, can you please change number 2? Change those c's to x's. X-intercepts, how do you find them? Plug 0 into y. Now solve for x. How am I going to solve for x? Well, x is squared, so factor. First question you ask yourself, is there a GCF? No. X method. -48 goes on the top, -8 goes on the bottom. Factors of -48 that make -8. Well, let's see. 6 and 8 make 48. That's not going to work. 12 and 4. Aha! Done. X minus 12. X plus 4 equals 0. Because I have an equal sign, I'm not done. Split up your answers. Over here, you get x equals 12. And over here, you get x equals -4. I just set these equal to 0 in my head, and I solve them. Number 3. Can you change those b's to x's? How do you find x-intercepts? Plug 0 into y. I don't see a y. Well, f of x means the same thing as y, so plug it into 0. Remember, in order to factor, what has to be true about your equation? It has to equal 0, which it does. Can I factor this? Yes. 55, -16. Factors of 55 that make -16. -11 and -5. So I'm not done. Over here, x equals 11. And over here, x equals 5. So let's now actually talk about what these values mean. These values are my x-intercepts. So if I go back up here to number 1, if I want to sketch my parabola, which I need to, I'm going to sketch one of my x-intercepts is at -4. My other x-intercept is at 1. And it's going to open upward. And it's going to go through those points. It's going to open upward because this first term is positive. So we're going to start sketching these because that's what this means. If I look at number 2, one x-intercept is at 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That's like over here somewhere. The other x-intercept is at -4. This number is positive, so it's opening up. Same thing for number 3. One's at 11. The other one's at 5. It's opening up because that's positive. It does not matter right now how low your parabola goes or how tiny your goes. It's just so you know that it's making this general shape. Okay? Number 4 is your responsibility for part of your homework. Let's keep going. Next examples. Find the roots. When you see the word roots, roots mean the same thing as x-intercepts. Whenever you hear the word x-intercept, how do you find it? Plug 0 into y. So, 0 into y. Ladies and gentlemen, how do I solve this? I have to factor. First question you ask yourself, is there a GCF? No. X method or slide and divide method? I got to do the slide and divide method. 10 on the top, -7. Factors of 10 that make -7, -5 and -2. I then have to divide both pieces by 2. -5 over 2 I can't simplify. This makes -1. So I have 2x minus 5, and I have x minus 1 equals 0. So I now have to split this up. So on the right, x equals 1. On the left, this might be a little bit harder to do in my head, so I'm just going to write it all out. I'm going to add 5 on both sides. I'm going to divide by 2. So x equals 5 over 2. So now it says sketch my graph. So okay. One x-intercept is at 1. The other one's at 5 over 2. So if I type 5 over 2 in my calculator, I get 2.5. So 2, 3, 2.5 is right there. And I'm going to just make a teeny tiny parabola. Next 2 problems are expectations of homework. Last section. Directions. Find the zeros of the following, then sketch the graph. Out of all those words, what word means the most? Zeros. Zeros means the exact same thing as x-intercepts. How do you find x-intercepts? Plug 0 into y. How am I going to solve this? Factor. Factor. First question you ask yourself, is there a GCF? No. X method or slide and divide method? X method. Factors of 6 that make 5. 2 and 3. So I have x plus 2, x plus 3. Not done. Oh, on my left, what's x? -2. On my right, what's left? -3. I now got to sketch my graph. -2, -3. It's opening up. Chances are it almost always opens up, and that's my parabola. It doesn't matter if I did that or if I did a parabola like that, as long as my parabola is only touching my x-axis at these 2 locations. 2 and 3 are also your expectations for homework. I will check this next class, and we will practice more problems next class as well.